Hello and welcome to this video, which is just about the AQA A-Level Computer Science NEA, which is such a big aspect of the A-Level course and one of the most difficult. When I think back to me at 16, 17, 18, would I have been able to do this? I'd like to think so, but it's a lot of work and takes a lot of willpower, motivation, determination, but definitely something which is such a good selling point of the AQA course. So this video is very specific to the AQA current specification, which is 7.5.17. There might be a future version which is different, and for other exam boards which have a similar NEA, this video won't really apply. So it's only really for the people studying AQA specifically. And as you can see by the length of the video, I'm going into quite a lot of detail. I'm going to go through each section of this NEA and give some tips and so on. Lots to cover, skip ahead if you need to, but I think really, if you're watching it having not started yet, actually understanding the entire project before you begin is quite important. And you might know this already, I would hope you do actually, but this fits into the A-Level as only 20% of the actual final grade. Paper 1 and Paper 2, the exams you'll do at the end of year 13, are more important in terms of the weighting. In terms of the time you might spend, proportionally, you might spend more time on the NEA than these two. You probably shouldn't, but occasionally that's how it is or how it can feel. And it's a lot of time you're spending on your own, potentially not really doing very much in lessons. Now, just to go through a couple of, I think, important, maybe you could say admin details of this. Well, this project is marked out of 75. By the way, the name NEA, project, coursework are all referring to the same thing here. So 75 marks, and these marks will be gained from 5 discrete sections, and each one will be in an actual report. Now these sections range from only 4 marks up to 27, and I'll go through each one a bit later on. But this report is important because essentially the way it works is your teacher will take in your work, you'll give your teacher, a long, very long Word document usually, they'll mark it and submit marks to AQA. And AQA will employ a moderator, and the moderator will sample your school and so have a look at a few projects from the school. The number will depend on how big the school is, and they'll check it potentially. You can't know for sure if you'll get checked or not, you've got to assume you will, and they'll decide if your teacher had given accurate marks or whether they should increase your marks or decrease them. It seems a bit old-fashioned potentially, but the way this works is your teacher will print out the project, or you'll print it for them, and the actual physical project will get sent to this moderator. So the moderator will look through this very chunky, usually report, and not actually run your code, not actually try and play around with your game, whatever it is. They'll just look at the code and look at the other sections, which should really influence how you demonstrate your program is working. But we'll come back to that later when we look at testing. Now, because this is moderated, we've got to say that marks are not ever final until results day. Your teacher might tell you your mark, they might not, but don't assume that's a final mark. It could go down, it could go up in a few rare cases, but ultimately the moderator is a person who will influence the exact mark you'll get along with your teacher, of course. And the project itself has got to be submitted to AQA in May of year 13. That may change, but it's been May up until now. But of course, your teacher may well need it earlier. The deadline your teacher sets is the deadline. It takes a long time to mark, and the earlier you get it done, the more you can focus on those 2 exams. Normally the 2 exams are in June. You don't want to be stressing about your NEA right up to early May, because really you should be preparing for Paper 1 pre-release or doing some Paper 2 revision. It shouldn't be dominating year 13 towards the end, ideally. So if your teacher's getting you to do it way early, that's a good thing. Right, okay, let me go through stage by stage the aspects of this project, which, despite it being a very long video, I'd recommend you go through, because having this sort of overview of how the project works is important, even if you haven't actually started it yet. So starting at the very beginning is where you are actually picking a project. As some of you will know, this can be difficult for certain people. It's something which you could be quite indecisive about. Ultimately, you can pick anything, and don't get pressured to pick something incredible and massively innovative and that's going to make you a billionaire, right? It can just be a simple project. It can be quite boring. What is important from a marking perspective is it has to be A-level standard. A-level standard is a phrase which is in the specification, and it's more for teachers to worry about but it's something I want you to be aware of because it can affect your marks and can affect your potential marks as well. So A-level standard, in effect, means your solution has to, or at least your aim has to be to do something algorithmically. What that means is there should be some processing going on. There should be some code which performs an algorithm which does something. It's not just a case of you designing a lovely menu or making a really simple website for a brand new business, right? The actual content is often secondary to what is actually running behind the scenes. Because we're doing computer science, not business or IT or something like that. So just to give you some ideas, which are just the first few I could think of, here are some potential projects which probably would be fine and would be considered A-level standard, and I'll say why. Often school is used to base projects on, which is often not very exciting for students, but is a perfectly fine scenario to base your projects on. So if you had, say, a program which allocated a timetable to different teachers, that could potentially be A-level standard because the allocation is actually very, very complicated. It's a problem with no efficient solution, actually. In reality, often teachers just do this by looking at a big spreadsheet. But if you had a program which somehow using maybe machine learning or a greedy algorithm or some other resource allocator, somehow you had an algorithm to approximate this, would be great. Another example might be a video game, which video games are naturally very, very popular. I'll say in a sec, we've got to be really careful with video games, but a good example might be if there is, say, a map that's generated dynamically, which gets progressively harder, would, because of that dynamic generation, potentially be A-level standard. Now, it doesn't have to be sort of Minecraft level, perfect generation really quickly and 3D and it's perfect. But if there is a way that it can adapt and maybe learn from what you've done in the past, that requires processing, that would be A-level standard. Another common area of projects are based around small businesses where you've got, say, stock management systems. And maybe a good example here might be not just a database with stock recorded in it, but actually the system is able to reorder the new products based on past trends, based on some predictions. That might require potentially quite a complex algorithm to do. It could be a very simple one, but you could try and make it as complex and quote unquote intelligent as you could. Now, to give some counter projects which probably wouldn't be a good choice and could really run you a risk of losing a lot of marks, even if they were done really well, you could still get brought down to be quite low. So if it was another school system, if it was just a case of having a database, it just stored details of teachers and classes, not enough. That's much more IT, being able to have a database. Even if you had SQL to kind of query it and get results, we're looking for some processing. It can be limited if you don't want to get massive amounts of marks, but it has to have some processing. Going back to video games, if we had a video game which looked nice and maybe someone made a really nice set of graphics, but ultimately the movement was really basic, just WASD, the NPCs were just random and didn't do much, not enough. Especially because we have things like Unity and there are so many tutorials and so much is done for you. Just a simple shooting game, not enough. And a kind of worse alternative for the stock management one, if you had just all the sales, again in a table, and there are some reports being generated, well, that generation could be conceived as processing, but ultimately it could just be a query. And a query you'd expect to have in many A-level projects, but just SQL is not sufficient for A-level computer science. Now, your teacher will be able to sort of vet your ideas and give you more specific guidance, and we are allowed to guide you towards a suitable project. And if they're not sure, they can always ask someone from AQA for their opinion as well. But it's really important to have a project which gives you enough room for more advanced stuff. You're causing yourself a lot of issues if you keep it really simple and don't bother designing anything with much processing. So some areas I would personally either avoid or be really, really cautious with are just databases. So if it's mostly just a database, even with a GUI stuck on top, not always enough, because what is a processing? What are you doing to the database which has got an algorithm? If it's just sorting and searching, I would say that's not enough. Games are a worry a lot of the time, because even if you make a really nice looking game, because there are so many tutorials and because so much is done for you, again, not always A-level standard. So often the 2D shooting games are really popular, I think because of Unity and Pygame and so on, but there's not a lot of processing going on, I'm afraid. A good example of making it A-level standard is networking. If you can get a network aspect so that you're playing against another human, that's often enough to tip it into A-level standard, but on its own, a local game with not much generation or clever NPCs is often not enough. And retro games are particularly difficult to get A-level standard. Things like Tetris, things like Space Invaders, there's got to be a way to make it a bit more advanced, which could be a network aspect or a leaderboard which is global, but just be careful. Quizzes, another area which are really popular but often not enough. A simple multiple choice quiz, you could make it A-level standard by having some algorithm which selects questions or generates questions or auto marks questions, but is an area I'd try and avoid or at least be really careful with. And finally, a lot of projects understandably mention AI, and it's clear the person's not really understood what that is. So if you are going to have AI, make sure it's suitable. Often true AI will be done on a big data set. So if you're collecting lots of data, AI might all be appropriate. If it is a 2D shooting game, AI may not be appropriate unless you've got a really clear way to train up the NPCs or something like that. So AI is something to be aware of, but make sure you research it before you commit to using it. Just a couple more things on this because it is important. Of course, this dictates what you're going to do for all of this time. There are two types of projects according to AQA. We've got problems and we've got investigations. Now, I've not seen thousands of projects, but I've seen quite a few projects. I've never come across an investigation, or at least I've never come across a pure investigation. I've seen a few which are kind of merged with problems. The difference is a problem is actually making software to solve a real life issue. Occasionally you'll see hardware as well, for example, programming an Arduino or something like that, but they're not as common. But there's a real life problem you're trying to solve. Whereas an investigation is actually research, so often trying out different techniques, comparing results, trying to find out something new. So much more sort of university style projects, which are fine to do. Like I said, I just haven't seen many of these. And if you're doing an investigation, it will tweak a few future things, like testing would be much more about looking at your results and comparing and analysing your results. So I'm not really going to talk much about investigations because, like I said, I've never come across one. They're not as common. So problems would be similar things to what I've talked about. It's not always a pressing, real life, urgent issue. A gap in the gaming market is not going to cause a huge problem, but that's a issue you are trying to solve, not an important one, but you are trying to solve it. Likewise, if a local business is complaining about their computer system, not life or death, but again, is a problem to be solved. And you would need to have end users to do this, and we'll mention that in a second when we look at analysis. So you've got to have a clear end user or end users in mind for a problem. Whereas investigation is much more, like I said, about comparing different things. The best example I can think of are you might try lots of different machine learning algorithms on different data sets and comparing and seeing how they are different and really digging deep into the data. University level potentially, but might be something you are keen to look into. It's just, like I said, a little bit harder because there's less out there for investigations. You will need a supervisor to guide you. Again, finding someone who's got the expertise might be tricky depending on your school or college. So the last thing I'll say about projects for now is try and pick one, of course, that you are interested in. It's going to take a lot of time. If you are bored to death with what you are making this about, it's going to make things even harder. But equally, if you've got a project which is so exciting to you, but it's ambitious, have a chat with your teacher, because you might find that actually it's better leaving that idea for a future day where you've got a bit more experience or a bit more time. Your $1 billion idea might have to wait because it might be too hard to do right now. Okay, let's start section by section, starting with analysis, which is worth 9 marks. I tend to think you should be getting very close to that, if not 9 marks, ideally, because there's a very, very set structure for this, I would say. Now, the purpose of analysis is setting out what your project is and why. So really being clear, what exactly are you doing and what are the reasons for this? So just as a quick acid test for whether you've written a good analysis, I would question, could anyone reading this understand what you're doing and why you are doing it? So not just a computer scientist, but could any reasonably intelligent person understand what is going on? That is a good sign that your analysis is towards the 9 marks. Now, the mark scheme is going to be really important to you. There is a mark scheme which teachers will mark and the moderator will check against. And I would suggest you are all over this mark scheme, understanding every word, because ultimately if your work matches up to the mark scheme and your teacher agrees, you're going to get very, very good marks. Now, I'd hope this website is not unfamiliar to you, but the specification on the website is really, really important for you to be reading a lot in all your subjects. A lot of it is not meant for you. You've got all of the subject content part of it, which is useful for revision and so on. But in this particular specification, towards the end, we've got stuff on the NEA down here. So I would suggest you printing this out and reading it if you've not already, because some of it I'm going to effectively repeat, but not all of it. But the mark scheme is given here, okay? And they're marked in levels. So the teacher marking it will have a look, what level does it most fit into? You might find you've got a couple from level 3 and a couple from level 1, and so it kind of averages out at level 2. And then within the levels, you get a particular mark, which again is kind of looking at, have you got 3 of the 4, is one a little bit weak? That might bring you down within a level. So I'd suggest you print this out and make sure you've got all of it covered. It's maddening as a teacher if a student misses something really obvious on the mark scheme, which they should have read, they should have spotted. So it's a good way of self-assessing, it's a good way of structuring your work. We'll come back to some of this other stuff a bit later. But just focusing on the top level, the highest marks, because that's what you want to aim for, even if you don't always get there. So, first of all, the first little paragraph is fully or nearly fully scoped analysis of a real problem presented in a way that a third party can understand. So effectively what I've just said. When it says fully scoped, that means you're going into detail and you're really going through exactly what this problem is. And so you'd be giving some background into this problem and potentially some research as well. So for example, if you are doing a program on a board game, or like you're implementing a board game in software, you'd go through the rules of a board game. How does it work? What are the key aspects to it so that anyone can understand it? Even if it's common, still go through it as if it's brand new to the person reading it. And you might research some alternative solutions potentially at this stage. The next paragraph, actually I would skip for now. Let's look at the third one. So the third paragraph is what personally I would now do in my analysis report. I would now focus on the end users. So the third paragraph says requirements arrived at by considering through dialogue the needs of the intended users of the system or recipients of the outcomes for investigative projects. So really, what do the users want? What is needed? And this dialogue usually means this will be in the form of an interview and or a survey. So a really good project I saw a while ago, somebody put a survey up in public with a QR code and he or she got a few hundred responses and it was questions about their idea. Great, like you're getting dialogue, you're getting data from end users. It can just be an interview. Maybe you're interviewing a business owner, your cousin, your friend if you need to use a friend. But ideally this end user is somebody who actually can give you a good idea, they've got an actual need and they can give you some concrete information. If it is your mate and you can't really get much from them, it shows to the marker and it might mean you go down a couple of levels in the worst case. And if you're just making up an end user, it can be hard to tell. The moderator's not going to investigate this thoroughly, but often it rings untrue if you're writing it yourself. So try and get a real end user and try and get dialogue. And ideally, what they're saying feeds into your requirements. So looking at the second paragraph, I'd personally put this after about the end users. So it says requirements fully documented in a set of measurable and appropriate specific objectives covering all required functionality of the solution or areas of investigation. So in an ideal world, we've got maybe a page, maybe 2 pages of really, really broken down requirements which clearly meet what the end user wants and clearly will help the problem you have previously identified. What I like is if people do this as a numbered list. So let's say you've got 8 high-level objectives. Well, for each of those 8, break it down into kind of sub-objectives or requirements for those objectives. So you've got 1.1, 1.2, 1.3, 1.4. Each one is a nice specific objective. So you can't break it down anymore, it can't be confused, it's not ambiguous, it's really clear and really broken down. And all that stuff I was saying about A-level standard earlier, it's essential this bit is good. Because if you stick down 4 objectives which are really high level and really, when I say high level I mean vague, so I will have a menu, I will have a database, I want the game to have shooting and or driving or something like that, right? Very vague. That is a risk because the moderator or the marker might feel it's not A-level standard. You've got to be ambitious in these objectives and you've got to make it clear that there will be some processing going on. So, for example, your objective might be, I will ensure the map generates based on previous levels of the game. Something along those lines, right? Where you've got some processing which is clear to the person reading it. Okay, now the last bit here is, I think the hardest to understand potentially. So it says problem sufficiently well modelled to be of use in subsequent stages. And really this is not necessarily at the end of this section, it might well come throughout. So modelling is quite hard to define, I would say. So my definition, which I'll take responsibility for, is providing the key information required to be able to understand how current solutions work, if there are current solutions, and how potential solutions could work. So modelling is all about providing a kind of a simple, clear, maybe not always totally detailed view of something. So what can be confusing is modelling is also quite a key part of the next section, which is called documented design. But the difference is analysis should be much more focused on the problem, less so the solution. So go into a bit more detail with documented design. The modelling in analysis is very abstract. Hopefully you're familiar with what abstract means. It's another kind of term for something being high level. It's where you are only really including the most important information. It's a bit vague actually, which is fine for analysis because it's just showing how things are structured, how things should be working, but without all the detail you'll need when you go to implement it. So really this will vary a lot depending on your project, so be really careful just chucking stuff in because I've said so. It will depend on what exactly you're doing. But often this will be something like a prototype. A prototype is usually a first go at the solution, or at least just a mock-up of how it might look like, just so you've got a better idea of how it's going to be, and you might use that later on in the next stage. I think an actual coded prototype can be so useful, especially if you've got a very ambitious project and you're not quite sure how it's going to work. You know, a good example is I saw recently a project using AI to do a board game, I think similar to Go. Very complicated, very difficult. And so what they did a prototype using a much simpler game, I think something like tic-tac-toe, and they used AI with tic-tac-toe, a much, much simpler game, just to see how the AI would work, and it meant they could apply that to the harder game later on. So it's helpful for you, not just the person reading it. Depending on what it is, you might want to do some worked examples, so going through a key algorithm potentially, maybe by hand. Again, I saw a project recently on Dijkstra's, and so they went through a few past exam questions on Dijkstra's by hand, just to show how it worked. That helped scope out the problem, which is how to do Dijkstra's. You might do a quite high level ER diagram if you're storing lots of data, if you have got a database, and so you're showing how different entities are related. I won't get too detailed here, I won't go into primary keys or the actual attributes at this stage, just the entities personally. Another common one I've seen quite a lot, again, is much more about where you've got a whole system working together, which are data flow diagrams. So they show how data moves for a system and might show roughly where does processing and storage occur, but just not go into loads of detail right now. And the point of you going through modeling is it prepares you for the next stage, which is documented design. This is where you're really starting to plan out your solution. So how it will be made and why it's going to be made like this. It's not why you're doing the solution, it's why are you designing it in this way. So justifying what you are doing is important. Now, another test this time for the second stage is, could another programmer read it and be able to take what you've said and make the solution? Analysis, I tend to think, should be much more about anybody should roughly understand it. Maybe not for diagrams always, but roughly they should understand it. But this time it's much more, could somebody else turn up and take what you've written and make a solution based on your design? That's the test for a complete documented design. Now, because of this, it shouldn't be too language specific. You shouldn't be going into loads of detail about exactly how you should code it in Python or C#. Ideally, most of it should be fairly abstract still, but you're now being more directive. I'm going to do this, you should be doing this, this is how it's going to work. Just maybe not going into precise detail just yet. But I wouldn't worry too much about that, it's just a guide. Now, at the highest marking level for this, up to 12 marks, you'll have a fully or nearly fully articulated design for a real problem that describes how all or almost all of the key aspects of a solution investigation are to be structured or are structured. So this is a very short marking point, and it can be tricky to mark because it really depends on the exact project. You've got to think, what are the most important things for somebody else if they were to code my project, which can be tricky, of course. Now, often it helps to follow a structure similar to this. This is personally what I would be doing. You could do something different, but personally, I would start with a very high-level overview of your system. So how does it work? What are the key parts? This could be a diagram, it could be just written text. Then I'd go through data structures. So what are you thinking you're going to have to need? Are you going to need a 2D array? Are you going to need a linked list, a queue, a graph, a tree? Ideally with some examples. If you are saying, oh, I've got this really important 2D array, well, great, what is going to be in that 2D array? Can you give some examples? Why have you chosen that structure? That would be useful. Then I would ideally go through the key algorithms. So what have you decided is needed? Which ones have you picked and why? So this is where having a strong project is important, because you need to have something algorithmically to talk about in documented design and of course to implement in code. Then potentially to slightly undermine my don't point at the top, you might want to get a little bit more specific about the solution. So what subroutines are you thinking are needed? How should the database be structured? And potentially even what specific queries are needed if you're using something like SQL to interact with a database. I would say at this point, you don't need a database. Lots of good projects don't have it at all. Lots of bad projects have a very good database. Often they're used. Don't get too put off if you don't feel you need a database. But I will say they do give you quite a lot of nice diagrams to bring in to these sections. So speaking of which, this section, in an ideal world, I would say, has a mix of both diagrams and text. Ideally, you've got the text to explain the diagrams and also justify your design choices. It really shows your understanding if you are explaining and justifying your rationale. Now, the actual diagrams massively depend on the project, but if I can give you a list of ones which I've often seen, that's what I'll do. All I would caution is, don't just put all of these in. I've definitely seen projects where people have just looked at exemplars, looked at lists like this, and put every single one in when actually it doesn't apply to their project. For example, if you haven't got a database, having an entity attribute relation diagram is a bit silly, right? This diagram, in my head, is a little bit more concrete than an ER diagram. You might actually show the primary keys, some of the attributes in this diagram. If you haven't got a object-oriented program, a UML diagram is again weird to put in, and not every project will have a graphical user interface. Again, you don't need to have one. In some cases, you should have one. For example, if your project is based on helping primary school children, having a command line interface would probably be a little bit questionable. But then again, if you've got a hardware project controlling a Raspberry Pi, having a GUI is a bit silly. So don't feel you need to include certain things. Don't feel forced to being used certain concepts. It's really about what fits with your project. Now, if I can point out a few of the ones here which I personally like in most projects, I think you've got to have some pseudocode. I would suggest not having loads of it, only what are the key algorithms. And in an ideal world, you'd actually show the algorithms working. Maybe a trace table, I say that cautiously, or at least a worked example of it working. And try and make it not language specific if you can. I also quite like subroutine listings, especially if you've got a UML diagram. You can kind of show what are the parameters, what are the return values, what should this subroutine be doing, because that's really useful if you're going to then code this UML diagram. I don't really like ipso diagrams personally, but they're quite popular. It depends on the project. So don't be afraid to be brave here and leave out certain things or rely more on text. As long as you cover all the main strands, that's important. And in reality, I would hope you start documented design before you start programming, because these diagrams are meant to help you. It's very hard to jump in on day one and start coding a complicated project. You should know roughly the structure, roughly what subroutines you're going to use, roughly what classes are you going to define. You should know this before you start, and so these are meant to help you plan. But we know in reality, very hard to know exactly what you're going to do before you start coding. So have some work done before you start programming, but of course go back and fix it and make it better and maybe add a few more. I'll say that quietly, add a few more before you actually submit. Okay, moving on to the technical solution, which is 42 marks. And this one is the least amount of work in terms of you putting it in your report, but it's the most amount of work because it's where your actual solution comes into it. Worth 42 marks, so more than half of your project. And there are two subsections to this. The first one is completeness, which is worth 15 marks, and the second one is called techniques used, which is worth 27 marks. Now, these are not headings in your report. Don't put these in your Word document. These are for the actual person marking it. But it is important to be aware of how you get marks in both of these two subsections. First of all, completeness. As the name would suggest, this is about how complete your project is. And so, to what extent does your project meet the objectives that you set out? So 15 marks would be you've met everything you need to do. But there's a slight exception to this. You might think a way to cheat the system a little bit is to set really unambitious objectives in analysis, so that the person marking it's like, well, if they've done these objectives, I better give 15 marks. Don't set weak, simple objectives, because completeness takes into account what the marker thinks could reasonably be expected from an A-level student. So if you've planned a quiz, but the quiz is multiple choice and command line and there's no database, you might only get a few marks in completeness because it's very, very unambitious, even if you were aiming to do what you've actually done. Equally, if you've met most of your objectives, but have got a couple which you didn't do, which were so ambitious, you wouldn't get penalised. You could still get full marks because this is really what you might expect from a A-level project. 15 out of 15 are for really, really strong projects. Now, techniques used is more of a headache because you can't do much about completeness, just trying to make a good solution. But techniques used, you've got more control over and you can be a little bit more strategic about getting these marks, I would say. So this is assessing how much skill are you showing in your technical solution. In your code, what techniques are being seen and how well are these being applied. So I tend to think of this as having 3 stages when you're marking it. First of all, you're thinking what techniques are being used, and the marker will be thinking, are they on the whole Group A, Group B, or Group C? And we'll come back to that in a second. The second stage is really thinking how effectively has the person applied these techniques. And thirdly, the marker is thinking, have they coded this in a nice style? Is it excellent, good, or basic? So these kind of sets of terms, Group A, Group B, Group C, and Excellent, Good and Basic, I've taken straight from the spec. So if we have a look under the mark scheme for techniques used, you can read it, and I would really suggest you print it and absorb all of this information. But it refers to Group A, Table 1, Group B, Table 1, etc. This is actually below the marking criteria. So if you go down a little bit, we've got example technical skills. And groups A, B, and C are just used as ways to categorize roughly what techniques fit what level. They don't refer to grades. It's not like you've got to get Group A skills to get an A. It's not like that, although Group A is the stronger end, Group C is the weaker end. Now make sure your project is aiming for, at the very least, Group B, but effectively Group A. Okay, because if your project only gives you scope to do Group C, have a very simple database, not really much point you doing this. You should be aiming higher and aiming for Group A and Group B. Now, Group A is quite a daunting list, I would say. You've got two columns. You've got the data structures on the left, and you've got the algorithms on the right. So we've got, the purely A-level data structures. We've got complex databases. So you've got several tables which are linked. You've got quite clear relationships between those, maybe they're normalized, etc. You've got cross-table parameterized SQL, so you've got SQL drawing data from several tables, etc. Right, so we've got the slightly more advanced things here. Some are very tricky, I would say. Other ones look easier. We'll come back to merge sort a bit later. Hashing is often included as a one line, which often isn't really sufficient. Group B is a little bit watered down, so you've maybe got a simple object-oriented model with maybe only a couple of classes which aren't really linked, as opposed to a complicated one with inheritance and aggregation and abstract classes, etc. So have a look at this. It's not an exhaustive list. You can have techniques which are not on the list which are Group A. A good example is AI. AI is not here for whatever reason. If you manage to apply a complicated AI to a video game or something along those lines, could well be Group A. So we first of all should be considering these example techniques when deciding on a project. If you've got a great project idea, but ultimately you can't really get anything from Group B or Group A, move away from it, or at least adapt it so that you've got scope to do something in Group A. And ideally, we're looking for a couple of skills from Group A at least. You might have, say, 4 skills from Group B and 2 from Group A, and that might bring you into the top level. It's sort of a rough average, okay? But it's not just having one thing in Group A, because if you've got lots of things from Group B, but one thing from Group A, you might still only be in the Group B level overall. It can be hard to mark this one, I have to say, especially because you're considering how well they're being applied. And so it's important not just to chuck in these techniques for no particular reason. Merge sort, I would say, is the biggest culprit. Because merge sort, the code is not particularly pleasant. It's got recursion, it's not the nicest bit of code, but ultimately you can find it online very quickly. So people see it on Group A and put it in their program for no good reason. The biggest culprit is where you've got SQL. If you've got a database and you've got SQL, you can just use order by and it will sort it for you. No need for merge sort. And so you wouldn't get credited if you just put it in and it wasn't useful. It's got to be relevant for your program. So when I say consider, I don't mean pick which ones you're going to use and force them into your project. I mean, does your project give you enough room to hit maybe a couple of Group A equivalent skills? Now, just going back to this third area, the coding style. Again, these are not my terms, excellent, good and basic. They come from AQA. And so again, an aspect which will place you within a band is your coding style. So basic, we've sort of got just sensible names. It's amazing how many people don't bother giving sensible names to things like variables and subroutines. Should be so easy. The annotations about comments, again, it's amazing how many people don't bother to comment their code at all. Good, kind of like lack of global variables, consistent. You've got a decent user interface if it's a GUI. Again, you don't need to have all of these. Not all of them are relevant for your project or even the language in the case of indentation. something like Python, that's not a factor at all. Excellent. We're looking for good validation, good exception handling. You've got maybe a few files with relevant connected subroutines. Maybe you've got a few different source files which are all doing one purpose. You've got subroutines used which are very tight and only do one thing. They don't affect each other. They're very limited. Their interface is very clear, etc. Your teacher can explain these if you're not sure what these mean. But again, print this out. Make sure before you submit, you've checked your code. It's got comments. It's got good names. It's got well broken down subroutines. It's the sort of thing you can tweak later on if you absolutely must. But ideally, good design would mean that these are fairly easy to do. Right? If you've got a really well designed UML diagram, you can implement it and you'll get excellent very easily. Now, actually you programming this technical solution is clearly a massive part of a project. It's the biggest part, and it can take you many hours to do. Okay, and the amount of time it will take you will really depend on your project. It will depend on your skill. It will depend on how many difficulties you encounter. It will depend on how good your planning was in the first place. Some people might be able to somehow code up their solution in a week. You know, at half term they just sacrifice to spend on a project. Other people need to spend, you know, a day every weekend for a few months working on a project. Depends on your approach, depends on your style. But when you've got a final project, actually putting it in the report is dead easy. I mean, really, it can just be a case of Control-C, Control-V, because ultimately your code has to be in this report, which gets printed and sent to the moderator. Make sure it's in full somewhere. Either just stick it under the technical solution subheading, or if you want to do something a little bit different, put it in the appendix, but the moderator and the marker have got to see the entire code so they can see how things fit together. If you've got several files, which often you will if you've got a good project, make sure it's clear which code belongs to which file, how they link together, and so on. So you don't have to do much writing here, if any, although I've seen some good projects where the person doing it has spent a few pages breaking down parts of their technical solution. So I said marking this section is quite difficult, partly because if you are doing an obscure project in a language I'm not familiar with and you've got some tricky algorithms, as much as the person marking it is an expert, occasionally you might miss some of the harder bits. You might not credit something as Group A when actually you would argue it is Group A. So it can be helpful if you have got some good stuff, you maybe just pick out that code and write about it, write about what it is, what you've done, how you did it, just to really signpost that it is, or it deserves good marks. Okay, so some self-assessment at this stage is useful for yourself, but also for the person marking it. But that's not needed. If you just paste in a code, that's fine. It's just, if you've got loads of code, something important could get missed. Unfortunately, we need to at least accept that. Now, this is where the length of your project will really get boosted. You might be kind of stuck around, 20, 30 pages by the time you get to the technical solution. This might well boost you up to 70 pages, say, depending on your code, right? The length of your code can really vary. It's impossible to really give an exact suggestion. It might be at a minimum, say, a few hundred lines of code, up to, many thousand lines of code. It really depends on what you're doing. How much code is boilerplate, is just, a set template. It just depends on the project. Okay, so don't get too deterred if your code is short or if your code is so long. It will just depend on what exactly you are doing. But of course, try and make it efficient and try and make it include those harder techniques. And just on the length of the previous sections, I said if you're at, say, 30 pages or so, analysis, I would say we're looking maybe between 7 and 15 pages. Of course, you could be a little bit less, a little bit more. Documented design can vary massively depending on how big your diagrams are, actually. But maybe similar, maybe a little bit longer. The length of your project overall is often between maybe 80 and 100 pages. I've seen some which are 400 and are ridiculous and are awful to have to look through. I've seen some which are like 30 pages, and that's 30, 400 are maybe signs you've done something a little bit wrong. Potentially you've either gone and done too much or have done too little, but don't obsess over the length of your project, because ultimately it's quality, not quantity. Now, just a couple of quick minor tips here. I would suggest actually copying and pasting the code. Screenshots are risky. When you have printed it, double check you can see all of it. If you've got screenshots, occasionally these are very, very small or blurry or go off the page. So check all of the code is visible, because you can't get marks if you can't see the code. Now, often if you copy and paste in the code, you just have it in black, which can be quite hard to read. If you can keep the colors, the syntax highlighting, that'd be amazing, and print it in color. There are certain packages, certain IDEs, which allow you to copy and paste it with color. So that might be a 10-minute job, which can help the person marking it. Moving on then to the penultimate section in your report, which is testing. So testing is worth 8 marks and is actually, it should be a fairly easy 8 marks, but it's really important. Now, the way these projects tend to get marked is the marker will tend to do analysis, do documented design, and then skip to testing, because testing lets them know effectively how good the project is. How much did you manage to do? Does the code work? Does it not work? This is where you are really proving what your solution does or doesn't. Okay, you've got to be honest with what's going on here. So a bad testing section can affect completeness, because the person marking it can't really tell what exactly has been done. Now, the highest level, so 7 or 8 marks, you've got clear evidence in the form of carefully selected representative samples that thorough testing has been carried out. This demonstrates the robustness of the complete or nearly complete solution / thoroughness of investigation, and that the requirements of a solution or investigation have been achieved. So very wordy. People tend to skip robustness, I would say, because it's kind of hidden in the middle. Now, what I would want if I was doing this, or what I would suggest my students do, a test table makes things nice and clear. I won't show you an exact example because the columns can vary, but we're looking for things like test number, test purpose, test data used, test results, and maybe a link to see some evidence, like see screenshot on page 80, for example. It should be explained. You've got to explain what you are doing. What is the test? What was the outcome? Has it been met? Has it not been met? That is important to get high marks in this section. Just pass, fail on its own is not really sufficient. Really important, these are linked back to requirements. Occasionally you'll get to testing and the tests don't match up at all with what they initially wanted to do. It should link. If you've got to go back and tweak analysis to match testing, fine. What I would like ideally is the test plan or test table to have something along the lines of, right, test number 5. This is for requirement 2.7. So you know exactly what it is testing and you can tick off that they've met that particular requirement. Videos. I would massively recommend, as difficult as it can be sometimes to record a video of you showing your solution working, just screenshots can be limiting, especially if there is motion in your solution. If there is a game, for example, and it's moving around, a screenshot can't show that well. You can't know, is it stuttering? Is it not stuttering? Is it working how it should do? It's hard to tell through screenshots. So it can be difficult depending on what you're working with. Don't have to do a voiceover, although it can be useful. Get some free screen recording software and just show you going through it. The best ones I've seen use videos as direct evidence. So the test table is like, right, test number 5, see timestamp 5 minutes to 6 minutes. They're really clear when should you be looking to see what aspect of the test. And make sure, as a last point, you test for robustness. This is whether your program breaks. Is it stable? Does it crash? Have you validated? Have you tested for things like SQL injection, if it is a database solution? Those sort of things are important to get top marks here. Again, videos can be used for that, or screenshots. If you are going to do a video, please be mindful the moderator is doing it on paper and isn't getting paid loads to do what they're doing. So they're not going to want to type in a million long YouTube links. Ideally, you'll be kind and provide a short link. A QR code is also a good idea. I'd provide some backup links. And if you are going to put it on YouTube, don't play around with it later. Don't change it from unlisted to private or make it public or delete it, because if they can't see your video, what can they do? Occasionally, I've seen only videos as evidence, and if a video link doesn't work, what can you do? It's going to massively affect this section and completeness. So videos are great, just provide a few ways to get to it, provide backups, and try and find a way which is stable. Another good kind of backup within the section itself are screenshots. So if you haven't got a video, make sure there are screenshots. But if you have got a video, having some screenshots as backup kind of mitigates against any issues with the moderator accessing the video. And my final kind of don't for testing is a bit of a personal thing. So if your teacher's saying something different, go with what your teacher says. Personally, I'm not a big fan of testing which is iterative. Now, there are two types of testing. You've got terminal testing, which is where you test your solution right after you've finished it. So all your code is done, you test it. Iterative is where you do a bit, you test it, fix any issues, do a bit more, test it, fix any issues. Now, that is how most programs are written, and that's great. I find it quite annoying in testing. We've got a long narrative. Like, I did this is broken, I fixed it. I did this, it was broken, I fixed it. Because it can be really hard to tell what exactly works, what doesn't work. Especially if evidence is repeated, I find it quite confusing. I prefer it if testing is, I've done my solution, here's what works, here's what doesn't work, and it's matched to the requirements. I don't really want a long narrative, but that's more my opinion, not so much what you need to do. The last section you should have in your report is evaluation, which is worth only 4 marks. It's quite hard to get 4 marks actually here. 3 marks is very easy, weirdly, but 4 marks can be a bit of a stretch for some people, but it is doable, of course. This section is where you are reflecting on the success of your project. So you are going on about what's good, what's bad, and be honest, right? The moderator, the examiner will know roughly how it's gone. And so you being honest about the flaws and areas that could be improved is really important, no matter how good it went. And if your project didn't go so well, which happens, it's a good chance to, show you've got understanding, show you were disappointed, or talk about what you found hard. Now, the highest level marking criteria for this is here. So we've got 3 paragraphs. I'd personally order it a little bit differently, but the first one is how I'd begin. So you're giving full consideration to how well the outcome meets all of its requirements. So here, get your requirements, copy and paste it in from analysis, and talk through what happened. Did you meet it? Did you not? How do you know if you met it? Just as much detail as you can do. The worst ones are where people are like, right, pass, fail, complete, fully met, etc. Discuss it. That's needed for the top mark band. And you could link this to the second paragraph. Personally, I would skip to the third one and then get some independent feedback of a useful and realistic nature, which you've evaluated and discussed in a meaningful way. This is often where people stick to 3 marks only because their feedback is weak. Ideally, you've got strong end users from analysis, and here you'd ask them again for their feedback, let them try your solution and see what they think, and then you should reflect on this. You don't just put in their comments, you write about what you think. Is it fair? Is it not fair? How would you address what they've said, etc. Now, the warning here is if you kind of are tired and don't really take this seriously, you might just include very shallow comments from so-called end users. I've seen things like, oh, it was incredible, well done, this is amazing, I've got no comments, I can't believe what you've done. And you look at the solution and it's pretty basic. So you're looking for realistic comments which you've evaluated, and it's why it pays to have a good end user from the first stage. Your friend might not give you very useful comments, and comments you write yourself can come across quite phony. Now, I would personally end by doing the second paragraph, so talking about how the outcome could be improved if you revisited it and you give it detailed consideration. So really this is summarising what you do differently if you did it again, what were the tricky bits, but also how could you extend it. So even if your project was amazing, what extensions are you thinking about? What ideas do you have? What would be really nice? And that should ideally link to what the end user has said. So this might be only a couple of pages, maybe a little bit more in some cases, but is a fairly short section. Okay, I want to end by going through some top tips. If you've managed to watch all of this and get to that point, amazing. If you've skipped ahead, fair enough. So first of all, going back to this whole idea of selecting projects, I've said similar things before in the video, but please don't feel pressure to pick a brilliant idea. Don't spend weeks and weeks and weeks deliberating and umming and ahhing and feeling kind of disappointed in yourself if you can't think of a great idea. Whatever you do, try and keep the scope simple, but it's essential there are areas which leave room to get advanced. So there's got to be one or two key algorithms which do something with your solution. So just an app or a website or a game is not enough. Find something which is going to do some processing, which will get you some marks. And look at Group A and try and get something similar in there as well. Okay, and look, try and make it interesting because it's a lot of time you'll be spending. In terms of the amount of time you'll be spending, like the length of the report, there is not a set number. It's very hard to know exactly how long it will take you. I would say we're talking, I'm reluctant to give a number, we're not talking about 10 hours here, we're talking about potentially 50, 100, maybe more, a lot of time over a long period of time. I've heard people try and do it in a half term or try and do it in a weekend even. Maybe you can. I wouldn't want to do that. So it's spaced out. Some projects clearly have had time spent on it month after month after month, and that's amazing, and they get great marks. So a lot of time, which links to my next point, right? It's daunting. This is a daunting project. I mentioned right at the very start quite negatively that if I was to do this when I was 16, 17, I would have found it hard. But it's doable if you manage your time. It's a really good preparation for university where you'll do similar projects which are arguably more important, right? You've got to bear in mind it's only 20% of your A-level, it's not all of it. At university, your dissertation will be, I think mine was about half of my final grade. So it's a good practice for real projects. Now, in terms of managing your time, the kind of advice I would give is start as early as you can. As soon as your teacher says go, get on it. It's easy without any time pressure to just let it pass and just let it slip into year 13, let it slip into spring of year 13, etc. It might be too late as you're watching, but if you have a chance to start early, please do. And plan. Don't just jump in. You might be really excited, you might be really eager, but take some time to consider all of the options, what requirements have you got, do some research into different options. Are there any good tutorials, any good textbooks on this topic? Do some proper research without all that pressure of deadlines approaching. And really, documented design is tricky, and often a lot of it is done after you've finished, actually, but some should be done before you start. So you've got a clear idea of how your solution will look, as well as a plan for how you're going to spend your time. You doing a schedule is not part of your report, but is useful for doing the report and doing the project. But based on this, adapt, okay? Set some initial requirements and make sure you're happy with them, but be prepared to adapt, change your idea if you need to. Try not to do a whole U-turn. I've had that before where someone comes back from Easter and it's different to what they had before Easter, which is a bit concerning. But adapt and be aware that that's fine. Now, you will get stuck. All of us, when coding, encounter errors, encounter situations where you've got no idea what to do, and that's really pressuring and I think quite draining. It's part of what's appealing to programming. It's very up and down, I would say. When you fix stuff, it's amazing, but when you get stuck, it can be very draining. Take breaks. Ideally, you haven't got time pressure. If you've started early, you can leave it a weekend, you can forget about it, and get a clear head. If you do get stuck, it's very easy to kind of put it off even more and procrastinate even more. I think my advice would be switch to a different area of a project, do some of your documentation. But ultimately, if you are totally stuck, wake up in the morning really early, get on it before you can really think about it. Because often I have spent weeks of my life annoyed with myself for being stuck. And then you actually spend half an hour trying to fix it and you fix it. So often the kind of putting it off is what makes it even more stressful. Now, what would have helped me a lot as a teenager is holding myself accountable, or more importantly, getting somebody else to hold me accountable. If you've done a schedule, you can get yourself, if you're determined, or somebody else to check where you're at, to check in with you, see how you're getting along. What I did at university was I would always do a time log. I would write down how long I'm spending on my project, so I can see, last week I only spent 7 hours, I should really spend a bit more, or even less, right? And often you'll look at the time log and think, actually, I spent 4 hours fiddling with something really minor. That was not a good use of my time. Much better if I focused on a more important feature. Okay, so ideally you've got requirements which are trickier. You've got some which are harder than others. Focus on the harder ones if you're able to, because if you put them off, which is, I think, human nature, stressful and risky. Having a weekend to implement a client-server relationship or add an AI to your game, tough. You might pull it off, you might not. So try and get it done early. Force yourself to if you need to. And the last one, don't just jump in. Okay, I mentioned about planning, but part of it will be ensuring your understanding is good. So, for example, you might be, okay, well, I want to do a game using Unity. Unity uses C#. I don't know C#, but I'm going to follow this tutorial and start doing it. What would be better is, ideally, if you spend a couple of weeks learning C# before starting the Unity project, just because at the start, you don't know what you don't know, and that could well affect you. You might find actually you can't do something you thought you could. But if you've got a better understanding before you actually begin, that's going to help you. Now, I would not procrastinate by spending weeks and weeks and weeks learning all of the intricacies of Swift or whatever language you're using, or this crazy web framework. Don't spend ages procrastinating learning all the details. Often getting started will help, but I just think people are so eager to get started, they don't really bother learning what they're doing, and they just try and cobble together lots of tutorials, and it never quite works out. You've got to have a good understanding to make the different areas work together. Okay, a few more quick fire points. I've got a lot to say about this, as you can tell. So if you can, especially early on, seek out some exemplars, so some past projects, ideally both high and low scoring. I tend to think often the exemplars teachers keep are the top ones, inevitably, because you want to show off, someone got 70 out of 75 last year, let's show this one off. Of course, they can be even more daunting when you see how good they look. So if you can see some low scoring ones, maybe in the 30s, 40s, 50s. 50s is decent, I would say, but it gives you more realism. What could you realistically get? It gives you a better idea of a standard. Your teacher, I'm sure, will have some. AQA provides some to teachers, and teachers tend to hoard this sort of thing as well. Now, I've shown you bits of the specification, bits of the mark scheme. Get on it, look at it all the time. There are moderators reports which give general feedback. A lot of the things, hopefully, I've said today are in those reports as well. I believe they are. And print the mark scheme, refer to it, double check you've got all of the big things. You might have left off testing for robustness. You might have left off some modeling, and you put it in and you get more marks. Now, because these projects are varied, very easy to be swayed by what your friends are doing. In your class, everyone should be doing something different. There might be similarities, especially if it is a big class, but there should be a difference between them. They might be the same language in certain cases, but often they won't be. Often someone will be brave and learn a new language, which is great. Don't be too swayed, okay? You might find your friends are doing amazingly, and you might feel a little bit disappointed or frustrated or afraid of what your progress is. Don't focus too much. Focus on what you're doing. You've got no idea if your friend is copying their code. You've got no idea if your friend who's saying they're not doing anything is actually working hard behind the scenes. Focus on yourself. Don't copy what they're doing. Do your own project. That's important. Okay, just a few more tips then. I am almost done with what I want to say. This one is massive, actually. Maybe I should have said this already. You need to appreciate you're going to have to learn a lot yourself. This is your project. You can pick any area you want. Your teacher, your fellow classmates are not going to know everything about your area. You can be really conservative and go for something which you know your teacher knows, but ideally you're brave and are going for something which you can really be an expert in, because you might well end up being, the expert on this in your school. Definitely there are projects I've marked which I've not been able to do myself, but hopefully you can still follow them and appreciate what techniques have been used. So a lot of it is you learning it yourself. You might have to learn a new language, you might have to learn a new framework, you might have to learn how to do certain diagrams when you're doing your modelling. It's work you're doing yourself, that's why you should reference stuff, but you need to be aware of this. Don't just stick with what you learn in school, because you might have not learned many of the Group A techniques. You need to ideally be doing a lot yourself. YouTube is amazing. You might be able to get textbooks if that particularly appeals to you. Things like Stack Overflow, things like GitHub might give you some ideas or give you some help on occasion. Just be really careful with what you do with it, because the reality is programmers borrow code a lot. You get stuck, you Google it. That's how most programming works. We can appreciate that. We can be honest about that. But this is coursework. It's giving you an important grade. You've got to be careful with what you do, right? So even if the code works, which often it will, it might be confusing. The code style might not be very good. It might even break other parts of your code if it's badly written. So don't just take everything you have without questioning it, without trying to improve it. But you could be plagiarizing. If you are taking whole chunks of code and not changing it, that's plagiarism. And look, it's printed out. The marker and the moderator have got paper copies. It can be hard to check. But if you look at some weird code and search up a couple of lines from it, and it comes up on GitHub, well, you've plagiarized it. And you could get no marks, you could get in a lot of trouble. So be really careful. If you've borrowed, say, a line from Stack Overflow, which fixed a weird error, just put a comment in with a link and just acknowledge it, just to be on the safe side. And if you've taken code, which is quite important, if you've based your project on a tutorial and most of the code is tutorial, you need to acknowledge that and say which code is yours, which code is not. Now, the final point I will say is a really important one. Look, this project is, I think, fantastic, really exciting. I don't want it to come across too negative. It is, I think, like I say, daunting at times, but ultimately a lot of people pick computer science to be able to make a website, to make an app, to make a game. And this project gives you a chance to do that, and you'll make something, hopefully, you'll be really proud of and really excited by. But the actual process is very up and down, right? Programming itself is a roller coaster, which is what appeals to a lot of people, including me. When you fix stuff and it's working, it's so satisfying. But of course, it can be quite low if things are not quite working. So please do ask your teacher for help. Ask for help online if you need to. Just be a little bit careful with what you're asking for and how much you're asking for. Because programming can be grueling. Be aware that you will get stuck. You will have times where you're bored or frustrated or want to give up. But you will get through it if you are determined. And it'll be the same for every single person doing every single A-level project. Your teacher can guide you. They can't tell you what to do specifically, both because of the exam board rules and because often, like I say, you'll know more than the teacher by the end, potentially. So they can guide you, they can give you advice. Please do ask for help if you need it. But final thing I'll say then is just a massive good luck. Like I say, really exciting project, really interesting and hopefully useful for your future life. But it's worth 20%. It will not take years and years and years of your life. But hopefully it goes really well. So best of luck.